The 2013 M3 Challenge problem asked students to quantify the growing plastic waste problem in the U.S. and recommend recycling solutions. At the competition finals in New York, judges, who were among those who reviewed the more than 1,000 papers submitted in this year's contest, shared their insights on the judging process as well as the qualities found in a viable solution paper.
It's a very intensive process, and by the time we're through with the 12 judges whom we assign to do this over a weekend in Philadelphia, they're pretty well worn out, but they enjoy the fact that they've managed to find some of the best young talent in mathematics in the country, we feel.
We learned these students are capable of solving problems, and they're capable of solving real or realistic modeling problems.
Judging is done in 3 rounds. The first round is triage, where each submission is read by 2 to 4 computation professionals. Most papers are eliminated in this round. Papers that make it through triage move on to the SIAM offices in Philadelphia for a second round of intense review and discussion. The consensus is reached over a 2-day period, determining the top 6 papers, the semifinalists, and the honorable mentions. In the final round, only the top 6 teams are invited to New York to present their solutions to the judges and validate the final rank order.
This contest models real-world problems. Real-world problems are known by the fact that they don't have neat, simple, straightforward solutions. So one of the things you have to do, as we did in this recycling problem, is to make assumptions that enable you to solve the problem in a reasonable period of time.
You really want people to fully address what's going on, be able to identify a final answer, and we want to see some creativity that may also be reasonable. Now this changes, I think, every year. The problems always change, so there's no one set formula.
Another thing that rose some of these papers here is looking at things like, well, we're doing a model, so we made some assumptions. How are our results, how sensitive are those to the assumptions that we made or the parameters that we chose? What happens if we vary those a little bit? That's called sensitivity analysis. So when we see students do that, that's a real plus.
The important thing is that they take those assumptions, work with them, and come up with a plan to address the questions that are asked. And the amount of creativity that they've demonstrated is a delight.
All these teams, they have addressed the problems in a way that was clear, understandable. They communicated mathematics really well. And that really, more than anything, that makes me happy. I want students to be exposed to math modeling, exposed to math in real-world situations. And this problem was able to do that successfully.